All right, so starting with 3.1 today, measures of central tendency. All right, some of these you may have come across already. Your mean in statistics, for the word average, we will be using mean. So very rarely will you see average. You'll see the word mean, but it means average. And so you'll find it the same way you would whenever you would calculate the average. You'll add up your data values and then divide by the number of data values that you have. All right. So if I have a data set of 1 through 5, and I want to know the average of that data set, then I will add up 1, 2, 3, 4, 5, divide by 5, because that's the number of data values that I have. 5 data values, divide by number 5. And my mean would be 3. All right. And of course, if I scroll up too fast or somebody's still copying, always feel free to let me know. As a matter of fact, let me write this like this. All right. Next method of measuring your tendencies, we're looking at your median. And if you're talking about median, you can think about the middle value. Think about the middle value. So first thing we would do here in order to calculate the mean or find the mean is you want to list your data values from least to greatest. So see, I said don't forget that. A lot of people for some reason forgets that first step. So make sure you don't forget that whenever you're trying to find the mean, the first thing you want to do is list your data values from least to greatest. Then if the number of data values is odd, you would take the middle value. If the number of data values is even, then you take the mean of the two middle values. Find the average of the two middle values.
Can you explain what you mean by take the mean of the two middle values?
Yeah, we're going to do an example. Yeah, we're going to do an example. And it probably look better when, once I put numbers on it. So yeah. But just basically taking the average of the two middle values. All right. So let's look at that first scenario, and we do a small values or small data set. So make sure we have a good understanding of what's going on. Let's look at this first data set. If I have the data set of 1, 2, 3, 4, 5, I have an odd number of data values. So if I have an odd number of data values, that means I actually have an odd or a middle value. Oh, let me quickly turn that blue. So that means I actually have a middle value, which would be 3. And so that is the median. Remember, your median just represents your middle value. It's the data value that splits your data set in half. So if you have an odd number of data values, you just find your middle value, and that would be your median. Okay. Now going to what your classmate just asked. All right. So if you have an even number of data values, you don't actually have a middle value. So what you're going to do is take the two middle values, which would be 3 and 4, and we're going to take the average of them. Remember, mean represents the average. So we're going to add them together and divide by 2. So we take 3 and the 4, add them together. That's 7 over 2, and that'll be 3.5. Remember, your median is the data value that splits your data set in half. Notice that 3.5 is right in between the 3 and the 4. So that will still split your data set in half. All right. Questions on that? Make sure we're okay. So if you have an odd number of data values, all you're going to do is choose the middle value, which would be 3.
So is it unsafe to say that when you have an even set, it won't always just be the lower number plus 0.5?
No, no.
Okay.
Yep, because if we were to spread this data set out wider, and let's say if my middle value, my two middle values, I have 35, and let's say it's 41, then, there's no guarantee. Like, you can have weird numbers going on, and you'll see when we get more data sets and stuff like that, you'll see the data values can vary. Yeah.
Oh, got you.
That,
So
so,
pertaining to whole numbers, then it could
yeah,
even,
right, right.
so whole numbers only. Okay.
Right, right. If it was like that, then yeah. So if you had, or if you just had integers like this, then yeah, that's a good observation. But yeah, your two middle values can be anything really. And so, all right, everybody okay with that before we look at the mode? All right. So mode, you can think about most. The data value that appears the most frequently will be your mode. It is possible to not have a mode. It is possible to have more than one mode, depending on how big your data set is. It is possible to have more than one mode. Bimodal is 2 modes. Multimodal is more than 2 modes. All right, so we had this data set 1, 2, 7, 8. Write that 8 better. 9, 6, 7, 5, 2, 9, 7, 6, 5, 1, 3, 4, 7. And they ask you what is the mode, and you would look through the data set and see which data value appears the most or the most frequently, and that would be the 7. 7 appears 4 times, which is more than any other value. All right, is everybody okay? All right. So a summary of data is said to be resistant if outliers, in other words, very extreme values, should have come across that term in your definitions, talking about very extreme values, whether very, very large or very, very small in comparison to your data set. So a summary of data is said to be resistant if outliers to the data set do not affect it. So show you what that means in a second. So let's go back to our data set of 1, 2, 3, 4, 5. We already established that the mean was 3 and the median was 3. All right. So now let's say if I add an outlier, say let's make 500 instead of leaving it as 5 or even making it close to the data set. 500 is very extreme in comparison to 1, 2, 3, and 4. So that would be considered an outlier. All right. So to find the mean, I would add those data values and then divide by 5 because it's 5 data values. So 1 plus 2 plus 3 plus 4 plus 500 is 510. Divide by 5, that'll be 102. So clearly the presence of an outlier changed or affected the mean because the mean was 3, but now it's 102. But if I take that same data set and look for the median is still going to be 3, the middle value. So that's what it means by outliers not affecting a summary of data. So this means that the median is resistant to outliers. An outlier existed and it didn't change the median. Any questions? Any questions? All right, so that's it for 3-1. Everybody okay before we go to 3-2? All right, see a thumbs up. Appreciate that. All right, so 3.2, measures of dispersion. Dispersion is the degree to which the data is spread out. I wrote that all types of sloppy, but all right, dispersion is the degree to which the data is spread out. So the first thing they talk about in this section is the range. It's the largest data value minus the smallest data value. All right, data set, once again, 1, 2, 3, 4, 5. You just take the 5 minus 1 and the range would be 4. Any problems? All right. Standard deviation. It measures how far a data value is from the mean. And we'll talk about how to calculate this in a second. All right, your variance is the standard deviation squared, and it's just another way to measure the spread of data. All right, is everybody okay? All right, so now this book doesn't hold you responsible or hold you to having to know how to calculate the variance or the standard deviation by hand, but you do need to have something reliable that can calculate it for you. So what you need to do is find an app, calculator, website, or something of that nature that will help you calculate the standard deviation and variance. Okay, I'm not holding you to knowing the formula, but you do need to have something reliable in order to be able to do so. So an example of that is easycalculation.com. I'll give you guys a chance to copy this, and I'll just show you that. You don't have to use easycalculation.com. If you have a calculator, that's fine. If you have an app, that's fine. You just want to make sure it's reliable. Yep, I was going to mention that one too, but somebody, one of your classmates mentioned Desmos. When you start Googling these things, Desmos will pop up. That's one that will pop up. And you just want to find something you're comfortable with and is reliable. Also, you don't want to find something that's going to make it more complicated than it has to be. In other words, if you are doing more than typing in the data value and hitting enter, then you're doing too much. Because a lot of free stuff out there and a lot of easy stuff, user-friendly stuff. So, all right. So here is a data set and that you can use just to verify your app. We got 6288. Guess I'll just take a picture of it. All right, I'm going to switch. Hold on, let me do this real quick. All right. So I would just do easy. No. Let's go standard deviation. Deviation calculator. Let's go easy calculation. So I typed in standard deviation, easy calculation. And the first one that popped up is easycalculation.com. Most definitely make sure you pay attention to the directions that the website or calculator that you use and give. So notice it says enter all numbers separated by comma. It doesn't say anything about space or anything like that. So I go 62, comma 88, 77, 68. Yeah, hit calculate, and there it is. So notice it gives you the population, standard deviation, the population variance, and that means these other two are your sample. All right. Questions on that? Questions on what we did there?
So we could use that on the test?
Mm-hmm. Yep.
All right.
Yep. All right. Anybody else before I leave the website? Go back to the notes. Everybody good? All right. All right. So, and this is the formula right here, as you wanted to know, but can be a little involved once you, especially if you once you get larger than 20 data values. But yeah. So let's look at notation. So the first thing is that we have X is going to represent our data value. No matter what you're dealing with, X is your data value. And then when you look at notation, notation is going to be important because you will get certain symbols that will let you know what you're dealing with, whether it be your population or the sample. Like, I don't know if you heard me, I just mentioned population variance, population standard deviation versus your sample variance and your sample standard deviation. Now, your population is an example. For an example, TCC, the whole student body would be the population. This class would be a sample out of that population. So for statistics, that matters. And you perform certain operations a certain way according to whether you have a population versus a sample. So here is Greek letter mu, when it's almost like a U, almost like an M, but it's not. Greek letter mu is a population mean. This is lowercase sigma. That's the population of your standard deviation, the population standard deviation. And this is capital letter sigma, which represents summation. I'm going to round group that's so small. Capital sigma just represents the addition of whatever value you're looking at. So summation, but here we're looking at lowercase sigma. So I just didn't want to say sigma, and some of you know Greek letters and try to figure out what that's not a sigma I've seen before. But yeah, this is lowercase sigma. That's the population standard deviation. Lowercase sigma squared is your population variance. And capital N is your population size. All right. X bar is your sample mean, and any letter with that bar over it, you would just say that letter bar. Like here, this would be Y bar. That's X bar. That's your sample mean. And this is just a simple letter S. That's your sample standard deviation. S squared is your sample variance. And then lowercase n is your sample size. So once again, you see these letters and you know if you're dealing with the population versus dealing with the sample. So if you see lowercase n, you already know that's your sample size, not your population size. And same thing with capital N, that's your population size. All right. Any question on those before we move forward? All right.
Do you have MN over the population mean?
No, that's mu, mu.
Oh,
Yeah,
okay.
Greek. Yeah, Greek letter mu. Just in case that's too small, this is mu. This is sigma. This is X bar. All right, can we scroll up? Is everybody good? I thought that was 3.2. Oh, it must be the latter part of 3.2. Okay. All right, so let's finish 3.2. All right, so the empirical rule says approximately 68% of the data is within one standard deviation of the mean. Approximately 95% of the data is within two standard deviations of the mean. Then approximately 99.7% of the data is within three standard deviations of the mean. All right, give you a second to copy that down. All right, it's a diagram that goes with this. All right, let me erase. All right, so within one standard deviation, in other words, we have our mean right here in the middle. If you were to add a standard deviation and subtract the standard deviation, that's right here, 68% of your data. And notice it reflects about the mean. We talked about this a little bit last class when we first introduced the bell-shaped curve. It reflects about the mean, symmetric about the mean. So whatever's going on this right side is also going on the left side. All right. So you see the percentages are going to be the same: 34, 13.5, 2.35, and 0.15. So I will magnify it. So you have your mean in the middle, add a standard deviation, subtract the standard deviation. So that's within one standard deviation of your mean. It's 68% of your data. If I add another standard deviation, subtract another standard deviation, down two standard deviations within the mean. So if you were to add up those four values, then that'd be 95% of your data. And then within three standard deviations of your mean, add and subtract another one. That gives us 99.7% of your data. And you know that's only 0.3 from 100%, and that's where these two tail pieces come into play. That's 0.15 on both sides, which is 0.3. We add them together, and that'll give you 100%. All right, give you a chance to copy that. All right, can I scroll up? All right, so let's look at this example. The mean IQ score of students enrolled at University A is 100, and the standard deviation is 16.1. Determine the percentage of students who have IQ scores within three standard deviations of the mean according to the empirical rule. Determine the percentage of students who have scores between 67.8 and 132.2. See if I can get that third one in there. All right. Determine percentage of students who have scores above 132.2. So I'll give you a chance to write it down. All right. So we write down our given information first. And in this case, I was just referencing the symbolism. Here, I decided to use mu. And what we're talking about, student IQ. So we're dealing with a population. So 100 for our mean. Standard deviation 16.1. And here I was just emphasizing, if we were dealing with sample, it would have been X bar and S for your standard deviation. Just trying to get you guys used to the symbolism. All right. So we don't necessarily need, for this first one, need to do the empirical rule, but I do want to go ahead and do it just so we can get an idea as to how it will work. Notice we have a right side of our mean, then the left side of our mean. So we're going to calculate the right side first, then calculate the left side. That's what I mean by this. So you take your mean, my green back. So what we're going to do here is take the mean, add 16.1 to it. Remember, we're talking about right here, 100 plus 16.1. So we add in the standard deviation, and that gives me 116.1. All right. Then we add 16.1 again. That gives me 132.2. Add 16.1 one more time. That'll give me 148.3. So that's what we mean going adding the standard deviation 3 times. That gives us 3 values to the right of our mean. Then on the left side, we're subtracting 16.1 3 different times. So doing it the first time gives us 83.9. Do it another time, 67.8. Then one more time, 51.7. All right, any problems? All right. So we have our mean in the middle. To the right, we have our 116.1, 132.2, 148.3. And to the left, 83.9, 67.8, 51.7. Notice our percentages in here did not change. Those stay the same. It's just the numbers at the bottom that will change according to the numbers that we have, or the numbers that we're given. All right, any problems before we go ahead and answer these questions? Everybody good? Everybody good? Okay. So we're going to come back down there. Just want to make sure we answer the question right. So determine, we're looking at A, determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. So like I said, we really didn't have to do any calculation to figure out A. We go back to the empirical rule, 99.7% of the students, 99.7% of the students will have, what do you want us to do? Have IQ scores within 3 standard deviations of the mean. So that's what that states right there. That's the empirical rule. Then going back, 95% of the students will be within 2 standard deviations of the mean. 68% of students will be within 1 standard deviation of the mean. So that's the empirical rule. So they were just asking you a conceptual question to the empirical rule. And that's what I wrote right here, just 99.7%. All right. B says determine the percentage of students who have scores between 67.8 and 132.2. So what you would do is just go to your values, 67.8, 132.2, and you would add the percentages between the two values. So that's 13.5, 34, 34, and 13.5. You add those together, you get that 95%. All right. Questions on that one? So this is something that they could ask. I know in the past we've had weather problems. So where you can predict weather according to based on previous observations. What's the chance? We getting this type of weather, whatever. It's a 34% chance. Stuff like that. So, but all of it will be based on previous years. Observing weather patterns of previous years and stuff like that. All right. Then C, determine percentage of students who have scores above 132.2. So you go to your 132.2 and you look at above, you're talking about these two values. So you add the 2.35 and the 0.15, that's 2.5.
Wait, what was the question for B again?
All right, here you go. Determine the percentage of students who have scored between 67.8 and 132.2.
All right, and then like those percentages are always the same, right?
Yes.
Yeah.
Mm-hmm. Yep. All right. Any questions? Any questions? Scroll. Very good. All right. So yeah, this trying to see how many. Yep. And then three. Yeah, thought so. Okay. So we don't have to do 3-3. 3-3 is not a part of what they hold you responsible for. So in chapter 3, all we have is 3-1, 3-2, 3-4, and 3-5. So I'm going to pause right here. Only reason is because I really could knock out all of chapter 3 in one class. And I'm trying to give you guys a chance to really get into my math lab. It's only been a week, right? Then that would be 3 chapters within 3 days. So I'm trying to, be cognizant and, of you guys and workload, class load, and everything like that. So we'll pause right here as far as new lecture is concerned. Next class, we'll do 3, 4, and 3, 5. That means we're going to be out of chapter 3 after the next class. So just trying to throw you guys a bone. Make sure you understand how quick this stuff can move. Next week, we'll be out of chapter 4. That'll be 4 chapters. So if you really, you got to get in there to my math lab, got to get flowing, and you can't take for granted that stuff might be easy and light and everything. And yes, it is light and easy, but you don't want to have a whole bunch of work sitting on you. No matter how light it is, you keep adding a whole bunch of light stuff, it'll get heavy. So make sure you take advantage of the fact that I'm not throwing any more new material at you right now. Like I said, come next class, we'll be out of 3 chapters. So you want to get this stuff, make sure you stay on top of it. Make sure you're flowing with this homework. Questions, and don't forget, not just homework, your first 2 tests. I think I posted both of your first 2 tests already. So the only one you have to do right now is chapter 1, chapter 2 test, which is your first test. But after chapter 4, then your second test will be something that you will be able to be responsible for. So don't forget, it's an 8-week class. So, we got to move a little bit. We have to move. Questions on anything before we close out today? Make sure we're good. So everybody good, everybody straight. All right. So you know what you guys have to do. Like I said, we're looking at chapter 1, chapter 2, halfway through chapter 3, and we will take care of that on next class. So if you don't have anything else, that's it for the lecture today. I will see you on next class, and we'll continue to move forward. All right. So you guys have a good one.
Thank you.
Thank you. You have a good one.
Thank
Take care.
you.
Take care.
I had a question.
Yep.
You said you were recording these. Where can I find them?
I'm going to send them. I didn't get a chance to generate the link from last class. So I'm going to send, normally I send them out on Friday evening. I just got bogged down this weekend, so I didn't get a chance to get them out to you. So I will send you an email that will have the links. And then I will actually archive it as well in Canvas announcements. So that even if you can't find that email, you can always go to your Canvas announcements and see that link.
All right. Gotcha. Thank you.
Right. Not a problem. All right. Thanks for the thumbs up. You guys have a good one. Yes.
Yeah, just one more quick question. So
Yeah.
we don't have any more definitions until chapter 10. So all we're responsible for is homework and tests.
Mm-hmm. You got it.
Is assignment 1 due for chapters 1 and 2?
That I'm not so sure I'm going to make you guys do. That's something I would really do in our 16-week class, but we only have 8 weeks. And I'm trying to make sure I give you guys a fair chance to, I want to keep hitting you guys with extra work. You know what I mean? So
Okay.
I wouldn't even worry about assignment 1 right now. Nah.
Okay.
All right.
All right. Thank you.
Not a problem. You have a good one.
You too.
All right. Take care.